Okay, this is lesson 5.3b, and in this lesson we're going to look at binomial common factoring and factoring by grouping. So note, a common factor does not only have to be a monomial, a single term, it can actually be a binomial. So if you find a greatest common factor that's a binomial, it's the same process. And I'm going to show you how that works. Here we have an expression. And if you look, what's common to this expression is this bracket. That bracket is common. Now, this is much easier to see if instead of the bracket, I just write a letter. So I'm going to write this right underneath so you can see it. So it's 2 times x plus 5 plus 3 times x plus 5. I'm going to change the bracket into the letter y. We've got 2xy plus 3y. And it's the same thing, I just replaced the bracket with the letter y. So what's common to both these terms? Well, 2 and 3 are both prime numbers, so there's no common number. There's no x in both terms, there's just this y. So we would say the greatest common factor is y, and we would divide the y out. We would say y is the common factor, and we're left with 2x plus 3. And if we replace that y back with the bracket, x plus 5, we get to the answer that we're going to get to by factoring out a binomial. So this is how come it works. I'm going to show you now without doing a substitution. So in this case, we can identify that that bracket is common to both terms. So our greatest common factor is x plus 5. So we're going to do the same process. We're going to write our greatest common factor down, and we're going to divide it out of our expression. 2x, x plus 5, sorry, 2x, x plus 5, plus 3, x plus 5. So if we divide the bracket out, what happens is the bracket goes away and you're left with just 2x. If we divide this bracket out, we're left with just 3. So now we write our answer to our division in a bracket, 2x plus 3, and we write our common factor in front. And that's exactly where we ended up on the scrap piece of paper over here. So that common factor doesn't have to be just a number or just a single term. It can be a binomial or a trinomial or any term in a bracket. So now what I want to try to do is I want to try to factor the greatest common factor that's a binomial without doing this division step. So I'm going to show you here, and we're just going to do a little bit of color coding. So here we have 3d times 2e plus 5d minus 7e times 2e plus 5d. If we recognize, the bracket appears twice. So that bracket is going to become our greatest common factor. And when factoring, we write our greatest common factor down first, 2e plus 5d. And now we take what's left over, 3d minus 7e, and that goes into our second bracket. And there we go. We have common factored a binomial without showing our work and in one step. And this is the point to which we want to get with our factor. And we want to be able to look at it, identify the common factor is this bracket, take it out, write it once, and then write what's left over in your second bracket. All right. So sometimes when you're common factoring, there's nothing common to every term. And in this situation, we can do something called factor by grouping. So let's take a look. We've got gx plus gy plus 3x plus 3y. If we look, g is only common to the first two terms. X is only common to this term and this term. Y is only common to this term, and the number 3 is only common to this term and this term. There is nothing that's common to all three terms. So what we can do in this circumstance is we can group pairs. And there's a lot of different ways to group. In this example, we're going to do a 2 by 2 grouping. So we're going to group the first two and the next two. And you might ask, does it matter which ones we group? Well, you group so that there's something in common. And by grouping the first two, I've got G in common in both. And by grouping the second two, I've got 3 in common for both. We didn't have to group it this way. We could have grouped, say, the terms with x's next to each other and the terms with y's next to each other. And that would look like this. Gx plus 3x, I'm just changing the order it's written, plus gy plus 3y. And now it's a different pair of things that are common, but we can still group. And I'm going to show both. So let's start with our first example. What was common to the first two was g. So we write g down. I'm going to highlight the g's so you can see. G, G. And then you write what's left over, x and y with a plus in the bracket, x plus y. And in our second pair, we've got 3 and 3, that's common. And what's left over is x plus y. Sorry, it was positive 3. That's important. Positive 3 and x plus y. And now, if we take a look, we have a common factor that's a bracket, x plus y. So we can common factor one more time. X plus y, x plus y. That's our common factor. And what we're left with is g plus 3. So that goes in our next bracket, g plus 3. And this is factor by grouping. Now I said you could group it a different way, and if that's true, we should end up with the same answer. So let's see. Gx plus 3x, what's common there is x, and we're left with g plus 3. What's common to the first or the next two is y, and it's plus in between, so plus y. And that would leave us with g plus 3 if we take the y's out. Now the bracket that's common is g plus 3. So we write that bracket down first, g plus 3. And what's left over is x plus y. And there we have it. The brackets are in different orders, but that doesn't matter because when you multiply, you can multiply in any order. 4 times 5 is the exact same as 5 times 4. Order doesn't matter. So this bracket before this bracket, or this bracket before this bracket, if we were to expand these, we would end up with the exact same answer, just the terms might be in a different order then. All right, one more example. Let's give it a shot. In this example, we've got 10p squared minus 15p plus 8p minus 12. So I'm going to group the first two and the last two. And you'll know grouping doesn't work if you group them and you try to common factor and there's nothing common. If there's nothing common from your chosen group, rearrange it and try to group something else. And if you get to this point and your brackets are different after you common factor, then factor by grouping isn't going to work. But let's try it. Let's see if it works. What's common to both 10 and 15? Well, the answer is 5. And what's common to p squared and p? The answer is p. So if we divide both these terms by 5p, what are we left with? 10 divided by 5 is 2. P squared divided by p is p. Negative 15 divided by 5 is negative 3. P divided by p leaves us with nothing. So common factoring out 5p from our first two terms leaves us with 2p minus 3. Second pair, we got 8 and 12. The number that's common there is 4, positive 4, really important. And in brackets, what are we left with? Well, 8p divided by 4 would leave us with 2p. Negative 12 divided by 4 would leave us with negative 3. So we're on the right track because we were able to common factor something out of both pairs. And now we know we're really on the right track because our brackets ended up the exact same. So now we're one step away from having an answer. Now we're going to common factor the bracket. So we write the bracket down first, 2p minus 3. And what we're left with goes in the second bracket, 5p plus 4. All right, and if you ever have doubt as to whether you did it right, you can always check by expanding. So I'm going to do that check over the side here. 2p minus 3 and 5p plus 4. Now, if we factored correctly, the expanding should give us exactly what we have up here. So let's try. Let's FOIL this out. 2p plus 5p gives us 10p squared. Perfect, that's our first term. On the right track so far. 2p plus 4 gives us 8p. That's one of our terms as well. Still going good. Negative 3 times 5p gives us negative 15p. That's another one of our terms. Awesome. And our last pair of multiplication is negative 3 times 4 is negative 12. That's our number on the end. We got it right. Now we can collect like terms and put it together and end up with negative 7p, but we could have collected like terms up here as well. But for the purposes of factoring by grouping, it was better to have the 4 terms. Okay, that's it for lesson 5.3b. Thanks for watching, and I'll see you next time.